Hello, good evening, and welcome back, everybody. So, today we are going to do a small experiment about AI and RAG. So, what is RAG? RAG is a retrieval augmented generation, how LLMs use tools to extract data and collect it with a bunch of text, numbers, images, everything. How it stores all those data into a vector database. It has to convert all those collected text data points, which could be visualized in a vector. You can do multiple things with it. Let's say I'm using a collection of data from a company. I've collected this data from a course. It's provided by Ed Dona. So you can visit his website and check out all of his courses. Okay, let's get back to data extraction. I'm using Cursor, and this file I'm running it locally. I'm using Python to code this project. We have important imports. We are using LangChain. I always get this question like, is LangChain the best architecture for building LLMs? My answer would always be no, because LangChain is one of the architecture to build an LLM, but it completely depends on what problem are you solving, what kind of tools do you want to use, and then decide what kind of architecture would be good for your AI. Let's do the imports. I'm using a small model of GPT 4.1 Nano. This would be suitable for my use case currently. We can go for a bigger model that takes a lot of token. For this video, we will stick with GPT 4.1 Nano. I have already provided the OpenAI API keys. It's good to go. So I'll have to provide some knowledge base, like where are those files and what kind of files and what kind of encodings we need to extract those files. Generally, for the text formats, we use UTF-8, but depends completely on your data. Let's extract the chunk of data. So it found 76 files in the knowledge base. Total character knowledge base is around 300,000 and above. Let's encode it. You can see the token usage because I called it. So 63,000 tokens have been utilized for just extracting the chunk. Okay, we haven't did any meaningful operations on that data yet. We just extracted the chunk and we have burnt already with these many tokens. Okay, let's do another operations. We have loaded all those 76 documents. We are using a text splitter. What it does is it takes all those documents, these 76 documents we have, it divides it into chunk size. This is a chunk size. We overlap it by 200. What is the chunk size? Let's say your document could be very huge. It could contain millions of pages, but we are chopping it into 1,000 chunk size and we will overlap it. Every chunk will be overlapped like this. Let's say this window is overlapping this. The overlap area is the connection between this chunk of text and this chunk of text. 200 is the overlap size and chunk size is 1,000. So we divided it into 413 chunks from 76 files. So we will take only 100 chunks. It could be as many as you want, but that will burn out a lot many tokens. So this depends on how much context do you need of that data. Okay, so I am taking 1,000 context window for those chunks. I've run it already. I'm rerunning it so that you could see it live. I'll have to take all those text embeddings, store it into a vector data store. So this code does nothing but it checks whether I have a database. If no, it will create one. That's what it basically does. It's a simple Python code. A vector store has been created with 413 documents with those chunks of data. We need to visualize it. So this code is for visualizing that there are 413 vectors on these dimensions they would be placed on. So we are ready with all the data and preparations, how we need to visualize. We also provide some UI related visualization. Our model is taking a list of few colors. I have taken 4 colors. You can add as many as you can, but completely depends on how much you want to mess up with your data. So 4 colors is minimal, which can help you understand the out level or high level of a company's operations. And these kind of points I am collecting for the data. So let's say products, employees, contacts, and company details, company operations basically. So let's go ahead. Yes. here is the 2D visualization. So you can hover over each point and see what kind of data it is. This is all employees data. This is all contacts, and these blue color points are products related data. This already shows connection between data points. Products are connected with contact. Some operations are happening. Employees are connected to the operations very much nearby. Here also you could see some yellow points, which already says that operations are also connected with products and contacts. Let's go ahead. This is a better visualization, 2D, but if you want to dive deep, if you want to see the connections properly or the relations properly between all those data points, let's run it in a 3D visualization. This is basically XYZ coordinates where all those data points are spread across those axis lines. Also forms the relation. You could see all those red data points, which were the contacts, and the blue ones were the products, and the green ones, which are employees data. These were the operations. And now you could see the relations more clearly. So this is a high level visualization of a small database of a company. This could depend. Let's say you are going for a unicorn which has been already serving for years in the market. You would have multiple data points and multiple colors which could be visualized, which could be more complex. This gives us an idea and helps us with the basic approach of how we can visualize data points on a vector database. Let's move to the next point, which is how do we know that this data is valid, or how do we even know that this data is actually relating? What measures are we taking? To understand those, it completely depends on how we have built the model, but we can write few tests. So let's do the evaluation, run the import. We have a file called test. In that we have some tests. How many? 150 length. And what kind of tests we have? Let's see. So we did a basic test which is asked a question to our model who won the prestigious IIoTY award in 2023. Our model has got the answer. It's Maxine Thompson, won the prestigious award of Ensure LM Innovator of the Year in 2023, which is absolutely right. So it is answering a basic question, but on what measurement? Is this answer accurate? How do you know that? That's what we are doing. We are trying to measure up how the model did, or how did it come up with that answer with some ratings or with some scorings. So let's run this. We already have this kind of data points. Let's say these terms, there could be many more terms. These are predefined or chosen. You can learn about these terms on EdDonor's website and courses. This is a direct fact check which gives you around 70 of the score, and then temporal scanning, numerical tests which didn't score well in because we didn't train the model for that. It is trained for answering simple question and answers from the database, not do much more complex calculations from it. That is why we have such kind of scores with the model. This is with the dashboard. I've used Gradio interface to visualize all those data points. Our retrieval evaluation. So I've run the tests. This is a visual representation of the tests we have been running to do the evaluation for the RAG system we have built with our current model and training data. It has mean reciprocal rank, which we call MRR, which represents to the meaning. Let's say whether the accuracy of the answer, the meaning of the answer was right. So we have a very low score in that, and also a normalized DCG, which is also a measurement of NDCG. You can definitely read more about this term of evaluation for AI models, and then how much coverage we have done through all of those chunks. These 150 tests we evaluated. These were the test terms we used to evaluate the average MRR. Let's say that direct fact, temporal checks, comparative, the numerical relationships between data, spanning how much your data relates to the next data. Does it has a close relationship or a very long time or distance relationships with that data? There are multiple data points which can evaluate to. Depends on what kind of evaluations you want to do on your model. Let's see the answer evaluation. This was the basic retrieval evaluation, and this is the answer evaluation we have run. So our answer is nearby okay accurate, not that good, because yellow indicates as okay and not good. So green is relevance. So our answer is completely good in score with relevance. Our 150 tests include these both things. We have answer evaluation and also the retrieval evaluation. And these are the same facts we checked for evaluation for our answer. So this is a small measurement for a model, but this could be more complex. If you have a more complex model for image generations, for video generations, audio generations, etc. So we are dealing with only text. So all we have is a bunch of text. That to a small amount of data collection we have. So we are able to do it in this short time. We can evaluate this with some data points, but this can completely tweaked and could be made more robust to understand a business or run operations on a business, to understand or evaluate data for a business. That's all for this RAG evaluation session. We will come up with more videos on LLM engineering and also how you could integrate LLM models into your mobile apps and also websites. So keep watching and connect with our social media platforms. Subscribe on the YouTube channel and also follow our Instagram page for latest update. We will come up with the next video very soon. Thank you.
Oh na na, that are the flow. Vector vibes now we know. Search and retrieve, let the answers grow. Score it high, let the dashboard glow. And packet dancing side to side. 3D clusters come alive. Test the truth, no place to hide. Rag and Evals enjoy the ride. Oh na na, watch it shine. Every connection by design. From the prompt to the finish line. AI working overtime. Oh na na, that the flow. Vector vibes now we know. Search and retrieve, let the answers grow. Score it high, let the dashboard glow. Oh na na, that the flow. Vector vibes now we know. Search and retrieve, let the answers grow. Score it high, let the dashboard know. Why da 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 da.